Okay, some problems from section 5.1, and this is verifying these identities. So I'm going to show that the left side of the equation equals the right side of the equation. So I'll work over the left for a while until I get the right. I'll try to do it from this side so it saves a little bit of space. I may write several equal signs over here. I'm not going to the right. I'm continuing to work on the left. And what I have is I've got one term over here, so I kind of want to get one term over here, so I'm going to try to combine these, so I'll have to write this as a fraction. So this 1, if I'm going to add to this, it's going to have the same denominator, so I'll write this as 1 plus the sine of x all over 1 minus cosine squared of x. Okay. I'm sorry, I should have said 1 plus the sine of x, pardon me. And that's 1. So I just rewrote 1 as 1 plus the sine of x over 1 plus the sine of x. And this stays the same, cosine squared of x over 1 plus sine of x. I'm going to continue this over here, so this is not this side. This is continuing over here. Just save space rather than writing it down using a whole sheet of paper. Hope that's okay. So what does this equal? This equals, I can put this all over a common denominator. So this would be 1, okay, plus the sine of x minus the cosine squared of x all over this 1 plus the sine of x. And we've talked about problems like this in class. Here we've got sine, 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 and cosine, and we don't have any kind of way of simplifying this in the form it's in, so we'll try to make it easier by maybe getting everything in terms of the sine. We've got everything in terms of the sine and cosine. Now let's try to make it even easier, get everything in terms of the sine. So this is going to be the same thing, so I'll write my fraction bar over here. This will be 1 plus the sine of x minus, and remember we talked about this identity before, the cosine squared of x is 1 minus the sine squared of x. And that's from our Pythagorean, you know, cosine squared plus sine squared equals 1, so we can easily find cosine squared in terms of sine squared and sine squared in terms of cosine squared. That's easy to do. And that's still all over 1 plus the sine of x. And this in turn is equal to, and then we'll just simplify 1 plus the sine of x. And that's going to be negative 1. And a negative times a negative is a positive. Sine squared of x. Again, all over this denominator. 1 plus the sine of x. And that in turn will be equal to, and then I can, 1 minus 1 is 0, so I've got the sine of x plus the sine squared of x all over 1 plus the sine of x. And then I can factor out a sine of x out of the top. And what's left is 1 plus the sine of x all over 1 plus the sine of x. And then I can just put a parenthesis around the bottom and think of this as 1 times is binomial, so those are cancel. And what's left is just the sine of x over 1, and that does equal what we started up here, the sine of x. So there you go. So that works out. Okay? So that's number 30. Let's take a look at number 33. A little messy here, so let me put a little blocking on this so we don't get confused here. So here's number 33. Now take a look at 33 and what we're trying to show, and the kind of the composition of what we've got. We've got a product here on the left. In other words, this is two things that are multiplied times each other. That's that times that. And then we've got a sum. So I've got to figure out a way to get a sum over here on the left if I want to match it up with a sum on the right or vice versa. So I'll try to get a sum on the left, and the way I'm going to do that is, remember, we have from our Pythagorean identities the other identities, and you can always derive them from the sine squared plus the cosine squared equals 1. As far as the secant is concerned, we know that 1 plus the tangent squared of x equals the secant squared of x. This is one of our other Pythagorean identities. We don't use it as much, but this is one we know. And that should be over there on your formulas. So what I'm going to do is, in order to get a sum here, because I have a sum here, I'm going to introduce this in this term. All right? Okay? So let's do that. So instead of writing the secant squared, I'll write 1 plus the tangent squared of x. And that goes from there. See, that's the same thing as that. And then that's going to introduce my positive sign. Okay? And then times the secant squared of x. And does that equal that? Now when I multiply this out using the distributive property, watch how nicely this starts to develop into something like this. If I multiply this, I've got the 1 times the secant squared, so I've got the secant squared of x times 1c plus the tangent squared of x times the cosecant. I hope I didn't say secant. I'm sorry. This is the cosecant squared of x times 1 plus the tangent squared of x gives me the cosecant squared of x, and then the tangent squared of x times the cosecant squared of x. And we're not too sure yet if that equals this. Now notice what we've got. I'll write this over again now. Secant squared of x plus cosecant squared of x. Now notice now I've got a sum now, and there's part of it. See, so I've already got half of what I've got, what I need. In other words, I need plus cosecant squared of x plus cosecant squared of x. So now I just need to make this look like this. I'm done. I just have to make this term look like that term. Okay? So again, we use this device here, this identity, to introduce a positive sign into a product because we have a positive sign in what we're trying to prove. Okay? Now the easiest way to do this is try to get everything in terms of the sine and cosine, and then kind of simplify it. Now remember, the secant squared is 1 over the cosine squared, so maybe we can get something like that going. So the tangent squared is equal to the what? Sine squared of x over the cosine squared of x, and the cosecant squared is 1 over sine squared of x. And I still have this CSC squared of x over here, the cosecant squared. Well, looky here, what happens? Well, the sine squares cancel, don't they? Sine there, so those cancel. So now I have plus 1 over and what's 1 over the cosine? One over the cosine is the cosecant. I'm sorry, 1 over the cosine is the secant, pardon me. 1 over the cosine of the secant, remember C and S go together. And that does indeed equal that's by the commutative property of addition. A plus B equals B plus A. That's our commutative property of addition. So we've got it. So that does check. All right, so there's your identity. Okay. So again, notice how we use this, and notice what motivated us. We needed to introduce a positive sign, so that's the way we did it. Okay, hope that helps.